we are going to get an expression for the equivalent resistance of a series combination of two resistors. Here you have two resistors in series combination. The equivalent resistance is defined regarding a combination of resistors. This is a single resistance that is called the equivalent resistance of this combination that is going to replace this combination. The principle of equivalency says that this replacement has to make no difference in the original circuit. Now we think the current I is sent to the combination from here, and this current has to go through this resistor R1 and the resistor R2. So you can see that the same current is going through these two resistors of the combination. Since the current is same, these two resistors are called as in series combination. So we think due to this current going through the R1, the voltage created through R1 is taken as V1 here, and this current through this R2 would create the voltage across that, say, V2, like this. If this combination is taken by breaking down from a network from 2 points A, B, like this, so of this combination, due to this current traveling through, the total voltage across the combination would be the voltage across A, B points. This voltage across points A, B would be the summation of this voltage of V1 and that voltage of V2, because of they are in series path. Now let's consider the same current is sent through a single resistor, which is called the equivalent resistance of this combination. The equivalent resistance is denoted by Req. Now what is the voltage created across Req due to this current? That is I Req. Now this voltage is taken as voltage V. From the principle of equivalency, when the same current traveling through the combination as well as through the equivalent resistor, the same voltage has to be generated, then same current, the same voltage, thereby making no difference in both cases. So this conceptual similarity means the equivalency regarding the electrical properties of the circuit. Now we are going to have an expression relating this expression between R1, R2 and the R equivalent. Now what is the principle behind this? From the principle of equivalency, we can write the expression from the principle of equivalency. This current creates the total voltage across the combination, that is V1 plus V2. The same voltage has to be generated through the single equivalent resistor when the same current is traveling through. Therefore this V has to be equal to that total V that is what the sum of the voltages across two resistors of R1 and R2. Now assuming both resistors as well as that one obey Ohm's law, now this voltage can be written as the current I times the equivalent resistor is Req equals this V1 is written regarding the resistor R1, that is what IR1 here, plus the voltage across R2 when the same current is traveling through. Therefore this voltage is IR2. Now you can get that more simplified, cancelling this I in the both side like this, becoming this equation giving the R equivalent as the sum of two resistors of the series combination. So this is what we are looking for in the context. So this is the result that we came up with the view of the same. Now consider an example where n resistors are in series combination. So when n number of resistors, each of resistance R are in series combination, the equivalent resistance Req is given by you can write this expression, so you can add them all, this the R equivalent, this equivalent resistance. Now you can add this n how many times? N times. Then you get the common factor are taken out, you get inside 1 plus 1 plus 1 plus 1 plus 1 plus, and how many times? N times. Therefore R times of n. This is another result that we often use when doing MCQ questions. So now let us consider the conceptual nature of the series combination of two resistors. Actually this combination is called series combination because of that is apparently as a series path like that. So conceptually the series combination is defined as the combination through which the current will be same and the voltages are additive. That is how we defined the series combination of resistors. So for the series combination, the first one, the current is same. Actually current through each resistor is same. Current is same, or current is constant. And the second one, the voltages are additive. Right. Now the important thing behind this derivation is the main principle of equivalency. This principle of equivalency indicates that the same current creating the same voltage across this combination as well as across the equivalent resistor, like this. So in the next video we can go for a sort of examples regarding this derived expression. Thank you very much.